So this is part 3 of the practice test review. So this question is very challenging because they require you to apply multiple knowledge and multiple concepts into dealing with these problems. So as you can see the drawing on the right, you only have an object basically being pulled up the incline with certain angle, right? And you have the force which is not parallel to the plane of the incline, but the force is being pulled at a certain angle. So now you have two different angles. And also when you read the question, let me go ahead and read the question for you. A man drags a 100-kilogram crate up the ramp of a truck, and the ramp is inclined at 20 degrees, and the man pulls at an angle of 30 degrees above the ramp. The coefficient of the friction between the crate and the ramp is 0.2. So as you can see that the coefficients must be less than 1, which you will apply this knowledge to solve the problem on the left, which is the drawn part right there. So you need to calculate the normal force and the minimum force the man would have to apply to pull the box up pull the crate up the ramp. And the minimum force would be the force required to pull the crate up the ramp at a constant velocity. By all means, is that a constant velocity means there's no acceleration, therefore sigma fx must be equal to 0. That's what you need to apply for the certain steps, okay? So now, let's go ahead and apply what you've learned, since the second 6th week about free body diagram. So, I'm just gonna go ahead and label the angle 1 and the angle 2. So, you have to be very strict in terms of what angle you're using right now. I'm putting right here as angle 1, which is the angle between the surface and the force, and angle 2 for me is the angle between the floor and the incline. So there are two different angles that you need to take into consideration when you're dealing with these test problems. So let's go ahead. An object, there must be a, let me go ahead and use the color so that you see what I mean by that. I'm going to use the different color. So, an object laying on the surface must have the force equal to gravity, which is mg. And since we only have one mass, so we don't have to label which mass it is. But also, with this one we have force, and therefore we have only one force, so that's why I'm telling you that it is only F. This is the force of applied, not the tension on this case. So you have to break the into x and y directions. So anything on the left or on the x direction, I'm going to use green. And anything in the y direction, I'm going to use purple, so you know what color it is. So let's go ahead and label the forces, which is the mass times cosine of angle 2, which is that angle right here. The angle is the same. So when you apply the concept of adjacent over hypotenuse, you will get the cosine right here. And also the weight, which is pulling it down, which is mg sine angle 2. So basically an object that has the weight will have the weight which will be very related to the angle mg cosine and mg sine. Those are the two forces you have. So an object is laying down on the floor or any surface by or me. In this case is the incline. So there must be a normal force. So let me go ahead and correct myself. So your normal force is in the y direction, so I'm going to use the purple one, which is M. And we're going to derive that n is not equal to this one because we have these additional forces that has certain angle. So you're going to have that to take into considerations. So this problem is no longer simple like what you would have done over here. So let's go ahead and this force right here, you're going to have to break it into an x and a y direction. So x direction, I'm going to write out F is equal to cosine angle 1. That's n, but this is F cosine. Sorry, I already have cosine there. I'm going to go ahead and put a sine. Angle 1. So now once you finish drawing all the forces, you're going to have to take into consideration and thinking about how many forces total are being applied to this box, which is an object. So you have how many forces in the x directions? 1, 2. Okay, let's go back and look at the question to see if there is any frictional force involved in this system. From reading the question, it says coefficient of the friction between the cleat and the ramp is 0.2. So basically, they're actually telling you that there is a coefficient. So if there is a coefficient, you know for sure that the frictional force is equal to mu A. That's one of the things that you need to remember, that the frictional force is equal to the coefficient times the normal force. Once the question is given to the question, okay, from this question, the coefficient, which is little mu right here, is given, and you can figure out the n from solving all the y direction here, and then therefore you will get a frictional force, and then you would take the frictional force into considerations. So let's go ahead and draw another force, which is the frictional force in the x direction. So let me go ahead and label that there. So that would be my FF, frictional force. So now, how many forces total in the x direction? 1, 2, 3. Same thing happens in the y direction, 1, 2, 3. So now first, like what we've said, we're gonna go ahead and apply what we've learned in the x, y direction first. And since the object is not, it doesn't say that it's being pulled up. Even though it actually pulled up at a certain angle, it doesn't say in this picture that the object is being lifted from the incline. So therefore you would have noticed or realized that the sigma Fy is equal to ma first. But then it's also equal to 0 because it's not moving up at a certain acceleration. So go ahead and apply all the forces that I have. So I'm just going to go ahead and take that into consideration. So how many forces are 2? So therefore I can combine it, right? So I will write a normal force plus F sine angle 1. Okay, this force right here, which is the weight, which is mt cosine delta 2. Oh, I'm so sorry. Let's go ahead and double check if the angle is right. Yes, because, okay, let's double check for you if the angle I assign is it right or wrong, and explain why, and justify your answer using an example that you've learned throughout the semester. You get extra credit for that. Stop pause. So basically it is correct. So normal force plus force of applied sine delta 1 minus mg cosine 2 because it's equal to 0 because it is the angle angle between the ramp and the incline. So the first question says that you need to figure out what the normal force is. So for this case, let me go ahead and isolate the n by itself. So therefore I will just go ahead and to get rid of this 2, I will go ahead and add f sine delta here, and I'll always like add mg cosine. So let's do a scratch work, right? And then I also do it on both sides of the equation. So that would be f. Oh, this one. Okay, basically, is it plus or plus minus? If you want to get rid of that, what do you have to do? Do you do the opposite or do you do this? Think about it. So the answer is you have to subtract, and that one you have to add. Therefore, I could cancel them out. So this one, I'm just going to go ahead. N is equal to f sine angle 1 plus mg cosine angle 2. So basically, in order for you to figure out what the normal force is, you have to know what F is. And in this case, you do not know what F is because question 2 will tell you what F is. So basically, this is very challenging because you're going to have to use what you've learned or what you derived or the equation, which is normal force is equal to the force of applied sine delta 1 plus the. Okay, let's double check the side again. You need to subtract there. So therefore, this will be negative. You're gonna need this one in just a minute when you're trying to figure out what the minimum force that needs to apply to create in order for the box to move up, at least at a certain velocity, at a constant velocity. Okay. Now let's go back to what we mean by that, by sigma fx is equal to ma. And in this case, it's also equal to 0. Let me go ahead and tell you because it says the velocity. Let me go ahead and double check if you can see this one. Okay. Velocity is constant. So if the velocity is constant, therefore it is equal to 0. So the summation of the forces in the expression must be equal to 0 in order for that, in order for the box to be moving up the incline a little bit. So let's go ahead and take the forces into consideration. So we have 3 forces in the x direction. So I'm gonna go ahead and write down the forces that I know for sure. Let's start with the one. So it would be mg side 2 minus F frictional force plus mg cosine 1 is equal to 0. So now let's go ahead and double check if it is right. So this one, since it is pointing to the left, so I'm going to have to put a negative side. The frictional force is pointing to the left, so I'm going to put it negative side also. And this one is pointing to the right. Based on our convention, it's positive. So now you have 3 different forces. Go ahead and do that one again. mg side minus, so now you know that F is mu. So I know what N is by substituting that F side is negative side plus mg cosine 2. And that would be the force of, that would be normal force plus F cosine 1 is equal to 0. So now, when you look at the equation, you are solving for the F. You have to figure out what the F is first by combining all the terms. Okay, let's double check how many F do you have. So basically, this is all your F. And that one. So for this one, you're going to have to solve for F, then you will substitute F in this equation. In equation 1 in order for you to get normal force See, as you can see, this is not a very simple equation, so it involves more steps. So from here, I'm gonna leave it up to you to solve the problem. So if you have any question, feel free to ask me in class because that's how we're gonna get you the answer. And you go ahead and use this as a template for you to practice for the practice exam, because on the test, I'll give you the same, this very similar situations with different number. That's why I'm not putting in the number right now. And for you, it is wise that you plug in the number at the end